regarding this week's learning objectives, you sure definitely know something about Ajax. Okay, and this Ajax is short for JavaScript, XML, HTTP requests. I know this is a load of stuff, and it's hard for me to even pronounce XML, HTTP requests every time I talk to people about this, and this is why people just call it Ajax. Okay, just call it Ajax. Ajax, then you find this is not your cleaning solution. Okay, Ajax. This is JavaScript communication messaging protocols, if you will. So we're going to learn about the concept. We're going to understand the benefit and reason why we're using it. We're going to familiarize yourself with the XML. So this is syntax. Okay, so in a PA, a whole bunch of PAs in CA, participation and more involved CAs, you'll learn about the syntax. We're going to learn the process, how these asynchronous requests goes in and out, and there's requests, there's responses. Okay, so this is two-way communications. If I were to draw, and this is allow me a second, let me bring out my annotation tool. Whenever you have let's say this is your client, oops, and this is your server, and server is like, I don't know, Google, and what's client? Client is your browser, right? This browser talks to the server remotely, and request is the one that you as in your browser sends to the server, and response, okay, RESP is what gets back. So we're going to study asynchronous requests, how you make requests from client browser, your HTML, CSS, right, or JavaScript, or all of them combined, to get the information to, and sometimes the requests and responses, they could have JSONs in it, right? So you can kind of see the flow here on its highest level. And then when the response comes back, you have to know how to handle this, right? Understand how to handle this. This involves looking at some code, and there's going to be quite a bit of examples in the third-party website link where you can deep link into those, like Wikipedia, to learn more about. Okay. Question: is Ajax the reason MathJax is called what it is? I don't know what MathJax is, to be honest. This Ajax is kind of the de facto way of fetching remote data ever since the early 2000s, and so there's a lot of history behind it. And this Ajax is like the most generic way of communicating data via HTTP. Okay, and it's browser based. Okay, browser. Like, for example, you would not use Ajax to communicate JavaScript, which is not part of your browser. But then, interestingly, if you look at the entire time frame from like early 2000 till now, right, and there is 2010 right in the middle, like towards the later part of 2010 or the beginning portion of it is when Ajax kind of loses its steam, right? Ajax is good from here to here. Right? And then later on, from like 2014, you have React. Like a lot of these simple page applications, they start adopting different tech stacks to communicate data. And so you have a lot of these frameworks out there, like Express.js, that helps you set up web pages, and they'll have their own sort of HTTP protocols. You also have Axios. Axios is HTTP library. I mean, there's a lot of that libraries out there that helps you communicate with a remote server from a client-server interaction standpoint since the advent of 2010. So our Ajax, in the context of this class, will focus on this time periods. But don't get me wrong, there's still a lot of developers out there making use of Ajax. I mean, you see newbies out there, their first project, they use Ajax. That's okay. Ajax is still around. It's still part of HTML. Sorry, not HTML, JavaScript, browser-based JavaScript. So you don't have to, reinvent, the wheel by having to adopt something different. Okay. And then we're going to spend a little more time to talk about third-party web API. We're going to look at what API is really about. API stands for Application Programming Interfaces, and then how to make API requests, right? So on and so forth. And there's a little bit of topics on REST, which is the architectural style governing the how we communicate data these days via HTTP. Okay, from a service to another service, client server standpoint. Does that make sense? Sounds good. Yep. All right, let me quickly erase this and move on with my cursor. Yeah, and that's pretty much it. So it's pretty web heavy today. So hopefully we get to learn all of them. Okay. All right. Yeah. If you're interested in becoming a web developer, this is like the ground zero table stakes that I would recommend that you get really, really, really familiar with. Okay. Even if the textbook doesn't talk about it, I want you to explore, for example, by going in any topics all the way to the end. There should be links. These are just some recommendations, but even you don't want to miss that. Okay. All right. Does anybody have any other questions in general? Cool. All right. We're gonna spend probably most time in this chapter section, this HTML HTTP request. So let me just take a step back, right, to like talk about this AJAX thing. So the history of AJAX, which stands for, actually it's not JavaScript thing I was talking about, it's asynchronous. Hold on a second. Wait, why is it not? Oh yeah, it's right there. Yeah, you'll see asynchronous JavaScript and HTML, right? So this is a technique that has been around since the early 2000s. So AJAX is a set of web development techniques that enables web pages to be updated asynchronously. Do you guys know what asynchronous means, right? Meaning if, I'm looking at this web page and you see like this other animation and things that pops up, and they are obviously not, part of that software, but there seems to be another software, I don't know, worker, right, in the back that kind of powers these things. And you don't have to like invoke it. It just shows up asynchronously at a set time, or they just pop up. These things are what we call asynchronous event, right? Kind of like, this class is synchronous, meaning we'll meet at a synchronous date and time each week. Asynchronous means things that could take care of itself on its own by another resources. Okay, that's kind of like what asynchronous event is. And when we're dealing with asynchronous requests, request is what you do, right, to tell the other web resource or server or program to give you back something as a response. So this is what AJAX is really about. It's just a collection of these libraries or techniques that enable asynchronous interactions on a website, for 20 years, 25 years. And it started with like iframe, remote scripting, and then it goes into like this AJAX mode in full force starting I think it was 2002. I was around at the time, and this is how you can do fabulous things with HTML, CSS, which was really, really novel at the time. But at the same time, it also opens up an opportunity, a career path, right, for lots of front-end developers who used to write a whole bunch of static HTML, CSS to drive certain things. So the web pages were still pretty much a novelty at the time. But you could do a lot of interactions, right? Great with AJAX. So this is kind of brought on AJAX to its current day popularity at the time. In 2004, it came with some standardization, like a whole bunch of people come together and, hey, let's standardize this thing. Let's standardize this method, its library, so other people can use it. And like in the middle of 2000, 2005 is when I remember it's when this whole thing just took off. It just instantly gained a popularity due to the advent of Google Map. And I don't know if you guys are old enough to, probably all of you, right, to remember when Google Map just came out. And it was incredible, right? So you can pen through this map from left to right and up and down. Like this is something that you couldn't do, but it was available at the time. They used AJAX, right? And then all of a sudden other companies, right, start to follow suit and say, hey, this AJAX is good. I can build something just like Google Map. So let's do it. right? So on and so forth. And then there's a whole bunch of jQuery stuff that comes out. This is kind of like the souped up version of, or the packaged version of Ajax, called jQuery, that simplifies the process of making Ajax. So there's a lot of libraries that are in a part of jQuery that allows you to simplify doing Ajax thing, right? So you can think of it as a helper, a declarative thing that you can do with Ajax and with jQuery to eliminate the need to have to get into a lot of details. So you can think of HTML as HTTP requests as like a pretty complicated thing that follows the standard SOP. This is procedure operation, operations standards. Whereas jQuery is just a number of methods that encapsulate and obfuscate a lot of these details, making invoking what you want to do asynchronously be pretty painless. That's where jQuery came in. Anyway, so there's jQuery for CSS, there's jQuery for JS. We'll talk a little more about that when we get to it. Okay, there's actually a jQuery section in this whole book. Honestly, I don't know if we can get there because this whole jQuery thing is after everything, pretty much after we're done. But I feel like just this chapter 8 alone is going to take us a very long time, all the way through to the end of the semester. Anywho, let's get through that. So any questions so far? So that was HTML HTTP request. So this is an object communicating web server using Ajax, blah, blah, blah. And then, yeah, let's look at some animation. I think this is the most fun part. So now you have a browser, and this browser has some HTML in it. And this HTML says movie info, right? It's pretty boring. All right. And then you have what's called the JavaScript. So let's see what happens. All right. So like I said, this Ajax thing, right, is able to send some requests over the web, HTTP requests. Okay. I think many of you came from my HTML CSS class, so you kind of know what HTTP is. It was part of that study, Internet Basic. All right, so don't worry about the implementation details, right? So this entire code basically says I'm going to instantiate an object of HTML HTTP request, and then I'm going to open socket, and I'm going to do get. So by the way, HTTP is based on TCP/IP. So there is this thing called socket that you have to open. So that's why you say open. So once you establish that whole connection using get, which is one of the HTTP method, I think I also mentioned this in my maybe earlier this earlier this course. I talked about these requests, right? This type. There's get, there's post, there's also put, and some of those are independent and some of those are non-independent. Anyway, this is a little more advanced, but you can issue these requests with whatever you want to include and send it over to the other side. Okay, so that's really what number 2 is. Number 3. All right, so this web server gets.info and say, hey, I'm going to send it back, right? So this is saying, hey, oh, sorry, no, the request is saying, let me get, right? Let me get or retrieve this starwars.html. So your web server returns that response with the starwars.html. All right, number 4. So request responses, right? So once the information is back, what happens? Well, this entire Ajax has a listener. So you guys know what a listener is, right? From last week. It's listening for this load event, meaning after this entire thing is this entire thing is being loaded, meaning inserted into memory. This function expression, anonymous function, is going to be invoked. Say movie info.inner.html equals this response. So whatever this response is, which is going to contain this start wars HTML, is going to be inner HTML. So inner HTML is where you put your textual data, and that inner HTML is what you see on the screen as a text. So now whatever is inside the star word information will be displayed according to your HTML. Make sense? So literally this example illustrates a couple of things. One is the establishment of that whole HTTP request and response. 2, that there's an active web server out there. So web server is really just another software, piece of software that communicates information through the internet, right? So like if you go to www.pcc.com, actually pasadena.edu, you get back, right, the index.html data back from the PCC server. That's web server right there. So this also illustrates the fact that you can use Ajax, right, to make requests and to receive responses back. And as a result, you can use JavaScript to do what? To store the return data, right, dynamically. And this is asynchronous, by the way. So if it takes like 5 minutes to get your data back from the web server, actually it shouldn't be 5 minutes, because in that case your HTTP is going to time out. And yeah, once that information is back, you set it to the inner HTML attributes of your web page, which is here, to effectuate the change. And yeah, whatever, the web server takes 2 milliseconds. Yeah, you may see this information pop up maybe 2 seconds later, because there's going to be a delay. Your web page is going to have to process that. Your JavaScript is going to have to link, right, to your web content to make those updates. So it could be a little while, maybe a couple seconds delay, and then you see the info. Does any of you have any questions regarding asynchronous HTTP request demonstration? So far, so good? Okay. All right, let me check the time. Make sure this is up. All right. Oh yeah. Yeah, so one thing I really want to talk about is the security thing. So it turns out you can't just, spin up a browser and, like your Google Chrome browser and expect your web server is going to be able to send you back the response. So if everyone were to do that, let's say, hey, Joseph is going to create a JavaScript and I want to talk to Google, I don't know, gmail.com. I want to fetch my email, right? Do you think I can do that? Do you think you can just create a JavaScript and say, hey, I'm going to connect to Google and I want to fetch my mail back? Right? Yeah, if everyone could do it, then Google will be out of business, right? For security reasons. They might be audited and people's data, those people trust and whatever. So for security reasons, there is something called cross-site scripting. And this is cross-origin HTTP request. What happens is when request is invoked on the client side, client is situated in some sort of website domain. So it's a web server. And these domains are really a collection, a cluster of servers, or something, that is got a specific DNS name tied to it, like google.com. So domain would be Google, right? Or it could be the, email.google.com, where that email is the domain. But anyway, so this cross-origin HTTP request is more like a security check that all of the browser sort of understands to ensure that the client, an only trusted client by the web server, by the server, could communicate data with each other. Does it make sense? So it kind of goes the other side as well, that, yeah, if the client doesn't recognize the web server and web server says, I am, Joseph, but you expect your web server to be end, then what happens? Yeah, you run into this cross-site, this cross-origin issues. And this is what's called CORS, okay? And yeah, in the industry, when you hear people saying, hey, there's a CORS problem right here, they meant cross-origin resource sharing. This could be easily mitigated by removing some of the security provisions, but not recommended. You can do that during development, but you don't do that when you are developing something in productions. Okay. Yeah. Does it make sense? Any questions? This is the course. Okay. And there's something called JSON with padding as well. Anyway, I believe there's maybe like resources that talks about these things. So this is maybe a side note, but I also made it as one of your learning objectives. So you will want to deep dive into this and still have questions. Let me know. All right. All right, so the step in using HTML HTTP request, one is to create an instance of that HTML HTTP request. You don't need to use any special libraries for it. You can simply just create instance of it, and this is how you would do it. In JavaScript, you can var this or you can let this, doesn't matter. Equals new, and then make sure that this is an constructor instruction, right? So this is literally a class that you need to instantiate, and then you assign a handler. You would basically do whatever the object is, dot add event listener, and then you take in 2 parameters, right? So that's what the API is, application programming interfaces for add event listener that takes in 2 parameters. You have to specify your HTTP methods, request type, and then you can also specify in the HTTP request header if needed. Okay, this is only if you need it. Like you can do set request header content type. You can say, hey, this content type is going to be JSON. Hey, this content type is going to be text. Hey, this content type is going to be binary. It's going to be encoded. You specify these things so that your web server can be prepared to use the corresponding decoding libraries or whichever it needs to serialize and deserialize the informations. Your content type specifies just that. And if you don't, and sometimes by default, the other web server expects that you send them a binary, but you end up sending text. That could be pretty ugly. And then you have these communication issues, starting with data inconsistency, right? Anyway, and then you will send the HTTP request via send method, and that is exactly what is illustrated here. Okay, yeah, you can copy and paste this entire thing and just do a test right now to ensure that this works. Okay, yeah, and make sure that you get familiar with 1 A, B, C, D, E, and then perform the participation activity. All right, so we can kind of look at this. I want you to do it because if I do it now and it becomes burned into the video and you won't do it. Creating a new HTML request is kind of like this, right? An object. Register means that you would attach to the listener, which is this guy right here. Send is pretty obvious. This is the very last one. Create load event listener is this. Okay. Register is dot add listener, but the load itself is this. And this is kind of the receive handler right here. Yeah, I think this is the creation. Yeah, this is what that means. I would say creating it to be invoked. All right, and there's a initialization of server connection, and this is where the open thing is. Okay, so this open is actually pretty loaded because it involves socket opening and closing. Any questions so far? No. Okay. So it turns out that there's a couple of results handler. One of them is the load, which we know is loading the, or your invocation methods and functions. There's also errors and abort and timeout. These are asynchronous, meaning if an error happens, then if you have this handler register, all of the errors will go into that handler, which is really another anonymous function that you would create. So you can actually load these up. Build. I'm sorry, not this load. You can actually build out these handler to handle load errors, or you can handle some abort when the browser is about to stop the request and then you want to do something to quickly close something. Let's say if you are receiving an error message, and when that happens, you don't want the user to stay on that page. That page should just be shut down. You can use abort. Yeah, I think we can go over some of the specifics, but I'm hoping maybe hold on a second. This will give you a lot of information. This is also my first time looking at it. I don't know if they have it. They do. Yeah, so remember these abort, errors, load, these are events. So they're classified as events for you to handle, right? So since this is the event, you can create your anonymous function. In this case, this is done through anonymous function. You can write function expression like you see here. Instead of using anonymous function or arrow function, sorry, you can write anonymous function as you saw it from the first this is anonymous function, right? You can turn this easily into an arrow function, which is ES5 or ES6 style right here. Okay, so any questions about associating these event types, okay, or various different AJAX events, if you will, to user custom specified functions or methods? Nope. That was good. Okay, good. Let's move on. Yeah, I'll leave you to the PA. All right, so next up is the progress handler. So this is a very interesting one. So it turns out that you can capture the percentage of the completions, and there's like different categories of when something is completed. Loaded start means when something begins to load. When you send a request out there and the timer starts to kick in, that is kind of the load, right? For sending a request. Load end means that when your response is retrieved. So load start, okay, as soon as this green arrow goes out of the page. Load end is when the HTTP response is received in its entirety, okay, by the browser. So you can think of load start as the beginning of your HTTP request, load end as the end at the end of your HTTP request, when you are about to gracefully connect or disconnect the connections, right, between browser and client server. And then, yeah, you can also do the progress handler to kind of to keep track of the amount of data that needs to be downloaded. So take a guess on how does your client or JavaScript know about the progress? Like, let's say if you're loading a whole bunch of like one image, and this image is big, right? High resolutions. How does your client who initiates that image fetch know that it is halfway through the download or 75% of the way through the download? How does that work?
Maybe getting the size of the file and seeing like how fast whatever's loaded so far has happened. I'm not sure, but like maybe the size of the file.
Yes, that's exactly what happens. So there's actually a couple of handshakes that goes out when you request something from a remote server. The very first thing is HTTP response, and if that information is a loaded data, the very first thing is going to get the HTTP header inside this response. You can inspect the header. Oh, there's a content size. It tells you, hey, this is 2 megabytes. Please be ready. And then there's that asynchronous download that happens in the back, right, through HTTP. The entire download depends on the use of your protocol. FTP, for example, is a different protocol than HTTP. HTTP uses TCP/IP socket, and you can also use TCP/IP, probably UDP, for data streaming, like videos. So they have, I think video uses a different protocol, but anyway, the important thing is these metadata that talks about the content of what you're about to receive is definitely the very first data that is received by the client. So that's how progress is made. Okay. Let's say if you're like 10% of the way through, your progress is going to give you that 10% data. That's generally the idea right behind this progress. So that way you can kind of display this dynamic download progress or indicator to the users for a better customer experience. That makes sense? Ooh. All right. Attributes for determining HTML request success. Yes, there's something called status, and this is a very important attribute that I really wanted to explain. Okay, so just like how much data you get from the other side, and along with a request, and typically a request object has a whole bunch of payload and data inside of it, and one of them is status, right? And this status information is important because depending on the number or the status code that you get, it indicates various different levels of success. And some of them are okay. And 200 usually indicates HTTP request is successful. So if you do, okay, and if I were to, let me see if I can probably do something like this. I'm gonna spin up a new tab, okay? And then I'm just gonna say let's inspect, and I'm gonna go through network. Okay, you guys can do this too, all right? And then we're gonna say, I don't know, for kicks, Pasadena.edu, right? All right, so this kicks off a whole lot of stuff on the screen, and some of those are HTTP requests, and you kind of see what they are, and like Pasadena.c, right? This is like the payload that I received by sending this request over, and the response is this, right? I get back from PC server, hey, this entire HTML, and my header is going to have information about the status code, right? There's request, there's a request method, there's status code. So status code is what I'm talking about here. When you issue something to the other side, you get back a response object. Your response object is going to have a status code. 200 means okay, means good. You have 300 plus. This generally means redirection, meaning your traffic is going to be redirected to another server for additional processing. 301 means permanent relocation. So, when you go to pasadena.edu, it doesn't take you anyway. So there's no 301. But sometimes when you hit a browser URL, it takes you to another URL. And that's what we call 301, error 301. It's not really errors, it's just a status code. And then there's 400. So 400 in general is never good, right? 403 means that there's a security thing, you can't access it. 400 means bad request in general. 404 means not found. So 400-ish level codes are never good. So is 500. So 500 plus typically means server errors. So let's say if your web page is experiencing, not web page, your web server is experiencing some issues to communicate to a database. And the client is not going to wait. It's not going to know what specific issue that is. But server knows. But server doesn't want you to know. So they give you a 500 error. So you get internal server errors 500, which is very confusing. And because you don't have the details, so it's not like you can debug into this issue, and people don't want you to know. You just don't know. But just know that if this is a 500, the issue is not you. The issue is that server right there, okay, that you're trying to connect. Does it make sense? All right. So should you, remember or memorize these status code? I say yes or no. Don't need to do the specific, but like you should know 200. Okay, you should know 404 at a minimum. You should know 500. So of the several of these, don't need to know everything, but some of it. I say 301, 302s. These are redirection messages that could be very helpful sometimes when your information is redirected. And those of you who took, I don't know if you guys have React navigation and React router, and that library redirects you to another page. Like for example, if you log out of your login form, when you log out, you get taken into a different page, right? That says, thank you for visiting our website, whatever. And that is a redirection out there. That's a 302, okay? 301. So yeah, more and more of these codes will make sense only if you have the experience of seeing it, okay? And as you get close, deeper and deeper into web developments, you'll see these things manifest in front of you. All right, I'm going to pause right here. Any questions about that, about this? So remember, status is not just, status is an object too, okay? So JavaScript gives back a response object, and that object has a whole bunch of objects inside. So one of the objects is status, right? Status is going to have its text that describe what the issue is, like HTTP request. I don't think it's going to say HTTP request successful. This is what's in the textbook. But your status text will have something that's pretty abbreviated. All right. You can also set this status tags if you like for other consumer to consume that info and do something with it. All right. Let's move on. Any questions so far? No? Good. All right. Quickly accessing AJAT response data. So response is coming back in the form of response object. It's going to have response text and response XML that you can fetch. So one example, let's just look at this animations together. So this is a website with HTML and JavaScript that, and this website is basically just a, let me see. Yeah, this is not a form, but this is just a simple input plus a search button. All right. And then your JavaScript is going to do get elements by ID, search, right? So search is an ID. Okay. And once you get the search button, the first thing you do is you attach a event, a synchronous event to it, listening for a click, right? So this click means the mouse click, right? Or if you are able to focus that search using your tap, like you can do this with keyboard, right? This is how people with visual impairments, they do that all the time because they can't use the mouse, but they can, use keyboards very quickly. And then you can get to the button and you can click enter, and that enter option will be emulating the mouse click as well. And that's going to invoke this function that creates an object that sends information out to the web server. So this object is created asynchronously when a click happens. Does it make sense? That's kind of like what this number one is. Number two, you want your entire Ajax object to have a response type JSON. So you want this other server that receives your request to respond with a JSON. So you can actually mandate that. Next up, we're going to keep going. We're going to say, hey, our title is this. So you're going to dynamically populate the titles. And by the way, this is all going into your request object, right? Your entire request object is this XHR. Okay. And then you can set the query string. You can dynamically mark up this thing too. And title value, this is called encoded URI component. This is very important because in HTML, I think there's some sort of default encoding that is applied to text. So you want to make sure that you get the right data out and not the encoded title, because then you're going to see a whole bunch of question mark, $signs, and these encoded values, right? So not good. Make sense? All right, so next up, yep, we're going to open connection and send it. So this is pretty simple. We're going to get using this lookup.htt PHP. Yeah, this is a PHP script with this query string. And this is what we are doing. So this PHP sits on the client side. This is something that you created. That PHP is not shown here, but it's a software, okay? That you create to process the informations by the web server. Does it make sense? Sorry, this lookup.php is sitting on the web server, not on yours. So your get simply says, hey, I'm going to go to the web server. At its default location, there should be a lookup.php based on the URL that you put in. And this PHP accepts key value pair called title equals, right? So get is key value pairs. And get means I want to get the information back. So then you send this request over to the other side. The web server takes this and says, hey, I need to process this key value pair inside my lookup.php, which is local on my web server. And whatever the result is after that PHP execution for lookup is what gets returned to the client. So let's look at the very first next one. Next one is the actual response. Now you can see this whole response object is in JSON. So you're going back to fetch this web server's job. By the way, this lookup.php looks up some resources on the website and returns that information back. Does it make sense? And this is the thing. Now, how does the client catch the response? Well, remember you had this, right? Search button at event listener. So as soon as, and you can see this at event listeners load, this asynchronous event is going to be fired when load, right? Technically, you can call it load end, right? That we talked about earlier. So when this load ends, meaning this entire HTML is this entire request is done, right? Now your response object is received. You invoke, and this is all done by JavaScript or Ajax. You invoke this method, which is this, right? This is the reason why after receiving this JSON, you can start to examine, right, what comes in. And the very first thing is to check to see the status of this object. So what is this, THIS? Well, remember, every asynchronous object, right, has its own worker or thread that has a specific resources that will be triggered. So this is that thread that is responsible for invoking this, right? So that's this. So this is a reference object pointing to the software resource that gets allocated asynchronously when this response object is received based on load signal, right? And then you call this dot status equals to, equals, by the way, this is the deep comparisons. If this equals the value 200, that means, okay, we're done. Then you want to fetch whatever's inside the response, like movie, and then try to, fetch that movie. And movie is, it's going to be this JSON, right? Which is an object, JSON object. You can convert that. And by the way, JSON object is just JavaScript object. And because they're interoperable, right? And then what's inside the JSON because you can see it right. And as a developer, you can fetch that data, individual attributes like movie dot title, movie dot rating year, and then dynamically construct your markup for HTML. This is HTML markup that gets displayed as an inner HTML. Okay, make sense? If the status is not 200, then just put up a generic banner and say, hey, movie data is not available. Any questions so far?
So if the payload is successful, I assume that that the request, the E tag is also updated, and then you could know whether you need to cache or not.
Triple double. Final.
What do you mean by cache? You mean?
Oh yeah, I mean, I think we had a discussion on previous lectures about like once you receive response from the web server, you get the status value and also the entity tag as well, and then that entity tag would be useful to check whether in future requests whether it's the same contents or not.
Yeah.
Right?
Yeah, just so you have this information at your disposal as a client. Yeah, you can decide to either cache that info for the next request or whatever you have to. But the most important thing is knowing what to do with the data. Yeah, I guess this example doesn't really do a lot. It simply just say, hey, just display that info, whatever, right? So if you look at the very next one, I'm pretty sure after clicking this search, which kicks off a synchronous request, which gets back a synchronous result, the outcome of this data is going to be displayed, like its entirety, parsed, okay, that gets disseminated on the HTML page, and so you see this, this thing pop up dynamically. All right, so this is a pretty good illustration of how how Ajax works. Okay, any questions? All right, I'm gonna have to skip all these PAs because you're supposed to do it anyway, so I don't want to do it. But I think what I gave you is pretty illustrative of the main stuff that you need to know. And sometimes you can see this response success. So the way to really like understand what's going on is go into this library, and then you can kind of look at the response object, and see what is available inside the response object. And this is what I call API, and it's very interactive because you can get into this and you can copy the entire JS. I believe if you go to a different website, maybe W3 School, they even have this embedded interactive IDE that allows you to play around with the data and compile them. Yeah, so there's a certain level of exploration that you want to get into, but ultimately, you know, this response it's got limited set of properties that you want to get used to. Okay, and I would say this is more catered towards like intermediate developers with some experience of this, so they use this all the time. But you want to get into W3 School, which is another link that gives you more, or I would say maybe a better understanding of how everything gets integrated. Okay, so let's go back. Any questions so far? All right, yeah, usually we spend the whole lectures on this Ajax, even though there's, you know, I want to focus on more modern approach. This Ajax is just, I mean, it's been around for a pretty long time. People still do it, but you know, just to see how cumbersome this is. Like, you, in order to just, you know, send an HTTP request, you have to write this much, right? Even though you don't copy and paste this, you know, you look at how other people did it, and actually you do copy and paste a lot than writing it yourself. But every time you send a request, you have to write this much code. That's a lot of work, right? So this is the reason why in the modern day, HTTP or Ajax stack, this whole thing is simplified greatly. So you don't have to write this, especially if you have to listen to a response data. That response data has a lot of stuff inside, and there's just a lot of business logic that you have to hard code them in, you know, into the parsing and the request parsing part of your code. And you know, that's really ground for future lack of maintainability. You know what I mean? Because once you start to insert these custom logic to handle something, and everything kind of just glued together, you know, in this giant block of code, and it becomes very unflexible, right, or inflexible, where your code is just looking to be very one-off and it's hard to extend in the future. Anyway, so this is a little more advanced. If you start to think big in a design standpoint, you will see the issue with this whole Ajax thing, right? Its mechanism is just getting way too complicated, in my opinion. All right, and we kind of talked about upload. Oh, so this is upload is for you to send information to the server. So you upload your picture or something. Same thing. You can upload, and you already know the size of your what you need to upload, and you can add the progress bar to it. Same thing on the other side too. If you know what you're going to be receiving, you can also kick off a progress bar, and it'll just take it from there. Okay, so you can try to experiment this progress event type to see how you can put up a percentage thing that informs the user how far away you are from completing this download or upload. All right, I said that I would be spending quite a bit of time on this, and I did for almost 1 hour. Questions about this? 7.9. Okay. Yeah, we're pretty much at top of the hour. So when we come back from the break, I'll give you guys 5 minutes. We'll look at using third-party web APIs. Okay. So why don't we do 5 minutes break? Let's be back at 7:38. Okay, 7:38. I see you back in 5 minutes.
stripe on the skin. Just like a name I remember hearing. Wild winters, warm coffee. Mom's gone. Do you love me? Blazing summer, cold coffee. Baby's gone. Do you love me? Wrap me in your arms. I can feel it burn. Rock me in your arms. I can feel it burn. Get up, get down. Get up, get down. Feel the turn rotation and start. See the next one waiting. Get up, get down. Get up, get down. Get up. Sitting the same with a pair of feet change. Get up, get down. Get up, get down. Feel the turn rotation and start. See the next one waiting. Get up, get down. Get up, get down. Get up. Sentiments same with a pair of feet change. Get up, get down. Get up, get down. Feel the rotation start. See the next one waiting. Get up, get down. Get up, get down. Get up. Sentiments the same with a pair of feet change. Get up, get down. Get up. See the next one waiting. Get up, get down. Get up, get down. Get up. Sentiments the same with a pair of feet change.
All right, folks, let's be back and resume our lectures. Okay, so the next section is 7.10, this is using third-party web APIs. And what is API? Well, API is application programming interfaces. This is, you can think of it as an entry point to invoke someone else's software. So if I ask you to write an API, for example, if I ask you to write a class in OOP language, some of those methods, these are APIs. Basically entry point. They're really just methods, but they're not really like your what you call the OOP methods, right? In a class, these APIs are really just they could be a web powered API that consists of a certain set of resources or different software that calls each other. So these API can be more involved, but in general, these web APIs, you can think of it as an entry point that you can, you know, supply some sort of parameters to it, kind of like executing a method or function to effectuate something, right? So a web API for logging user in, that one takes username and password, and you send them through HTTP. So that's a web API, right? So Google Map API has a lot of those specification that allows you to emulate a map applications. Instagram API, there's Twitter API or X API, Facebook API, GitHub API, so on and so forth. Does anybody have any questions about what is a web API in general? Right? Third party means those things don't belong to you, right? It belongs to somebody. So this is it. So a lot of times when third party or these website, Google, Facebook, Meta, they provide a set of APIs for you to invoke their services to do something. They have some sort of security in mind, and these things are what we call API keys. So these API keys are very consumer specific. So in other words, if I give you an example of, let's say two things talking to each other. You invoke this API. Let's say there's an API call you're trying to invoke. You would invoke this API. Let's say, x.com/login username equal, like, you would not do this, right? Because you don't want to expose your username and password in a plain sight. But I'm just using this as an example. This is HTTP GET, so it's x.com. Well, maybe I'll do something else. Okay, maybe I'll say info /info ? Data equals 5. Okay, so this is just an example. You use HTTP and you send this via this is what we call GET, right? So that's kind of that. But then what is this API key? Well, it turns out this API key sort of had to be embedded inside this GET request. And a lot of times it could be inside a body or whichever. There is a field where you insert this API key. It's part of the whole transaction. And this API key authenticates who you are and tells the server, which is here, and this is you right here, okay? That, hey, I am so-and-so, and this is my key. Can I get that info from you, right? Equal data equals 5. If this key matches whatever the server has on their side and said, yeah, this is the right key that also authorizes you, right, this specific person, to have access to that data, then this server will send it to you, right? Will be data response. This will be a data response object, RESP, okay, data response. So that's kind of the what API key is really about. And Professor, how do you generate this API key? How do you sync in? Well, yeah, that's a good question. Yeah, if you ever use what's called API gateway. So this is external services that regulates informations basically on the same level as control plane as let's say a load balancer that governs the network traffic. You can have the request be attached to a key, which basically means every single request coming from you has to go through that whole API gateway, and they will attach a key, along with your request, and they know who you are because you send it to them, right? And so they kind of regulate and orchestrate the information on your behalf as a proxy. You can think of it as a proxy, and that provides a lot of security. If you're developing this entire application, you might as well just send the key to the server and have the server cache it, on their end. So this is kind of a manual way of doing things. But anyway, I just want to explain what the API key is for. Does it make sense? Any questions about API keys in general? All right, so this is, and it also provides what's called rate limiting, meaning, if this is coming from Joe, he's got only 5 requests per month, right? If Joe makes the 6th request, he's gonna have to pay, right? So there's a lot of that stuff going on, with the API key to identify who this person is, and this person is authorized to access, let's say, 2 of the 5 resources provided by google.com, because this person is not a paid member of YouTube, right? But if this person is the paid member of YouTube Premium, then he or she gets to see basically everything inside of it without any ads. All right, fine. There's an API key associated with that whole request, right? Going back and forth. All right, so that was just an example of that. Let's look at REST web API. So what is a RESTful web API? So first of all, REST stands for, I think there is data. I'm trying to think. It should be representational state transfer application programming interface. I know it's quite loaded. So REST stands for representational state transfer. Okay, and this is you can think of it as an architectural style that was created by some PhD, some guy out there. I think he went to UC Irvine or something back in the early days, and so this became kind of the de facto standard that you see how web can transact information from each other. So this networking style is for designing network applications. It's supposed to be like scalable, simple, and stateless, right? Meaning transactional information do not get stored on either side, but somehow they understood each other. So yeah, this whole RESTful web API is one lecture at the minimum in a traditional web development courses, but we can only give you high level here. But just note that whichever web API that is making use of this entire REST architectural style way of transacting info is what we call RESTful API. Okay, so we probably heard RESTful, right? RESTful is just a plural for indicating that this entire practice is REST bound. Okay, includes REST style, which stands for representational state transfer. Okay, REST, representational state transfer. Questions? All right, so just quickly, right? I mean, what the heck is RESTful, right? So in this architectural design paradigm, right, you gotta have this mental model. It has a set of resources. They're considered this software as a resources, by the way. And there's communications out there that are stateless, meaning there's not going to be any dropped side effects. Meaning servers should not store any information about the client and any information between the requests. And every single client request to the server has to have all of the information needed understood by the server for execution, so that you get back the response as intended. So there's a lot of the stateless communication thing that involves in this, right? And from an HTTP standpoint, I already talked about there's get, there's post, there's put, there's delete. So RESTful APIs make use of these standard HTTP methods, so on and so forth, to exchange data. There's also representations, like how would you communicate data in what format? In RESTful web APIs, they said you can use JSON. Okay, you can also use XML. As long as these informations are something that client server can understand, you can use them, right? So typically, you set the content type to indicate what that information is, and so there's that common understanding and handshakes that happens, all governed by this RESTful web API architectural style designs, right? That put forth this whole ecosystems of web APIs that could be used and invoked, by the server and client to transact network data. All right. So there's a load of stuff, right, that happens. Does it make any sense? Or maybe do you guys have any questions so far about this thing right here? All right, I'm not going to go through SOAP, and you can think of SOAP as like very 90 and early 2000-ish. It's a very, very heavy protocol that, it's so complicated and involves so many trips back and forth that it just, wane in popularities over time. And people don't use it anymore. I don't use SOAP-based web API anymore. And I don't think anybody does. Maybe for very old applications are still functioning out there, but yeah, most of the time people use RESTful web API, just so you know. Okay. All right, so we don't need to spend too much time on SOAP. Oh, question. If I went to a website, for example, Spotify, and pulled their API, how would I be able to use it? Can you provide an example? Yes. So the very first thing you do is register on Spotify as a certified developers. And I don't know what the registration process is. That gives you the key. So you need API keys as a as a developer. So once you become their developer and have access to their development kit, you will have access to their library that you can compile into your JavaScript, for example, or Java, depending on what your backend services is, that will connect to their server. And two, as a registered developer, you get access and you have your developer key that you can attach to. And usually this developer key can be rotated from time to time. Some websites, they just give you this hard-coded value, and then if you lose it, you basically have to maybe make another one or something with them. Yeah, and these API resources, depending on your level of access, you should be able to make direct, HTTP requests against it. And a lot of times, these resources, they could also be backend driven, meaning they don't use JavaScript. They will have Java library or C++ library for you to compile your stuff into, and just make use of the HTTP libraries that's part of the library to connect with them. And see, so these are what we call client libraries that you can download, and you have to follow the very specific information that they give you to compile that into your code, so that you can do a backend transaction. But if this is like a very generic web API, then it could be as simple as just making a curl request or HTTP request if you want to write them in JavaScript. If you do React or some other single page applications, you can use Axio HTTP library to make essentially the fetch, right? Right now we don't use Ajax anymore. There's a sync and await, a synchronous method or promises that you can use to chain your entire request over. Then I would think at places like Spotify with web API access should give you access to these things. Anyway, so that's a very long-winded answer to your question. Does that answer your questions? I hope. Yeah. Cool. All right. There is no problem. There is a weather API. So this is one example of some third-party API that you can use, and you can kind of see this thing is kind of free. So I'm going to click into it, and which means, yeah, there's API documentation. All right, and then you kind of just read this. How do you start? Right, you read the whole thing, and this is an example of web where you can make web transactions by doing this API call. So API calls means this exact mechanism that you can copy and paste into your JavaScript. Okay, in the context of JavaScript, you can do that. And this is the parameters that you would specify, and these things that's required, then you have to do it. So you issue a call there. This is an example, including all of the required parameters, and then you can get back the response. This is the example response that you get back. As you can see here, this is JSON. This is JSON object, okay, with a whole bunch of arrays and objects inside, key value pairs that we talked about last time. And what do you do with this data? It's totally up to you, right? So that's one example of that. I don't know what this subscribe is. I think this gives you probably most up-to-date API changes over time, like releases, right? Updates and what's changed, what's different, what's new. So I can do that. Yeah, I didn't even know this web API is actually free. That's pretty cool. Anyway, let's go back. And then, yeah, developers registration. So you can see registration, you get API key. So this is very similar to Spotify, I would imagine. And yeah, then you can build your own website, making use of their API to fetch weather stuff. And this weather is requires the zip code. Yeah, and then unit like standard or metrics. Yeah, and your app ID. That's pretty simple. So yeah, if you have this information in with API key, and normally you wouldn't, first of all, you wouldn't do a HTTP GET because you're it's like putting your password, right, in the open. Like anybody who does the man in the middle attack can sniff this thing. This is how website gets hacked. Yeah, you don't do this. You'll do maybe an HTTP post, okay? So that information is part of the HTTP body and exposed like this. All right, so the upshot is you're getting back a result, and this is a JSON object. Again, when you send a request over, you can specify the content type to be a JSON or text. Okay, application-text or something like that to get to get back a non-binary. Okay. Yeah, and then yeah, please do this. This is your, I believe this is, yeah, there's a PA that goes in. Yeah, do this on your own time, please, and see if this makes sense to you. And if you don't get anything back, ping me on Slack. All right, any questions so far about this weather API? All right, so next up is cross-origin requests. This is CORS. We talked about this, right? In JSON with padding. This is a technique to prevent cross-origin restrictions. Because once you issue a request, your domain from where this request is from does not match the domain name of where this request is going to. This other server that takes your request is going to reject you. And this is a pretty frustrating experience because you don't get the information you need, even though you have the right API keys and stuff like that. All right, and this is what happens when you make a request, right? You have the right API keys. And if you get back access control allow origins to be start, that means anybody would have access to it. Then this is one way of opening this up. You would say if the API requests accept the request, API response with access control header indicating the same value at origin request, or this, which is the wildcard, that request is allowed from any origin. Okay, so if you are if you're like, let's say Google, right, or maybe Spotify, on the server, they're gonna have access control allow origin to be maybe start.spotify.com, right? So if your request is not from spotify.com, you're not going to get anything back. But like if Spotify would open this thing and say, hey, anybody would have access to they'll give you access control allow origin start. Okay. So a lot of this is driven from the server and not from the client. Because your client cannot force your server, who's like the gatekeeper for all the data, right, to give out its information. So this has to be regulated on a server side. And the good news is, as a developer, you have access to a server. You build your web application on a server, right? You don't build client applications only, you build the server side too. So you can build this, right, into the server that you want it to do. So that's really the basis behind CORS, or JSONP. Okay, so there are two things. So these are this is just one of the examples using CORS to bypass it. All right, then you also have calling with a JavaScript. I think we talked about this. You can use the HTML request. Let's just quickly take a look. And after that, I think we're pretty much set because I'm running kind of short on time. Yeah, the very first one is the get weather zip. This issues a request to this web page. We call it endpoint with the API key query string. So you construct the entire query string and append it to the URL, right? And you basically set the whole HTTP AJAX request by attaching a listener to it, response type, open and send. Next up, this is the construction of the whole get that allows you to fetch data info from this open weather map resource with this information that we talked about earlier, like the zip code, the unit being imperial, app ID being your API key, and the response object is a JSON. And this whole JSON will be unfolded asynchronously when the information is load, right? Load, like finish loading. And this information gets retrieved dynamically at that time and be parsed and pumped into inner HTML. Let's see what happens next. All right, so information is inspected. Status 200 means let's go ahead and do it, right? This is done. And then you just unfold that info parsed. Right, so this is, I think this participation activity is very similar to the ones that we had for like an hour ago, right? We did something very similar. Any questions about this? Cool. Yeah, there's a public API on GitHub. I never used this myself, but you can try to do it. This is not really maintained anymore, but it should still be pretty current, so you can make use of this and see if you can create something good. And there's some examples that you can look at by clicking into it, like the animal ones. Okay. Yeah, these are, I'm not gonna sign in. All right, let's go back. So that is, so we spent a lot of time on these two topics, right? One is the AJAX request, but so far we haven't really learned the modern stack. It turns out there's something newer than AJAX, and I hope we get to touch it maybe next time. Yeah, but before we get going, there's one more topic that I want to talk about, and that is consolidating all these various different idiosyncrasies together. How do you come up with something that works across so many browsers? And they all behave differently, right? So there's what you see is what you get. There's also what WG is not what I meant there. So yeah, these consortium or group of developers, they decide to standardize how browser may be released, fetched, and be able to aggregate data from time to time. And so this information is encapsulated a lot of times into what's called like jQueries and some, they call it cross-platform APIs that allows you to kind of communicate with each other, even though they are distinct, okay? Distinctly different or much different behavior-wise. So you have to support these idiosyncrasies by coming up with something that can become a cross-bridge communication vehicles. Like you would think these browsers will all be the same, right? But they're from different companies, right? Developed by different developers and groups of people. And so this is really what the history, right, behind how things get supported, and you can kind of see. Can I use this? So I think this is just one of the examples of how someone put together some statistics that tracks the features that are actively being used in this. So this is more about for your information purposes here, to see the evolutions of various different standards being used, and across different browsers. So we have Edge, IE. I think IE is deprecated by Microsoft. Firefox is still in use. Chrome, Safari, Opera, iOS, Safari. These are still pretty popular, right? And there's mobile handsets out there, and you kind of see the the arrow functions, the versions used. Okay, so let's move on. Yeah, so this is very interesting. You probably see polyfills, and upon looking at it, you would think, oh, this is some sort of graphical user interface thing, right? Like polyfill, what are they trying to fill? So it turns out this polyfill is a filler for determining how different browsers are to each other. And this allows you, it's basically JavaScript code, right? And that provides the missing standard functionality for other browsers. So on a pretty old browser, as in like 4 or 5 years ago, and if you know the browser needs this support, you use polyfill instead. So this is a library that you can download, and they'll have support for widgets, videos, audio, geolocation, and things like that. Okay, and so you have to try this out a lot of times to see it work. So if you were to have a date input element that is not supported by a browser, then in that case, the browser will treat the date input box as an ordinary text input field instead of this, right? So what's on the left side is if the browser supports it. On the right side is the browser that does not support it, right? So you would want to insert the polyfill for supporting this date input. You can use a modernizer and the jQuery date picker. And this is where you kind of use these collections of libraries out there and say, hey, this jQuery and modernizer support this version of browser, then you can download them. In that case, like I said before, using jQuery is like declarative. You can write very short amount of code to get the the styles that you need. So in this case, you use the two like combinations of two different libraries to effectuate this, right? Modern things that does not exist on an older browser. Modernizer is used to determine whether a date input is supported, and then jQuery is for the date picker. So jQuery comes up with a whole bunch of libraries out there that gives you this functionality. So you don't have to build this entire calendars from scratch. You can simply just use the type date. And this is supported in the jQuery, like here, in terms of the, picking the certain things, it's going to depress this button, and then you see the gray out button that gets selected. So these are all part of the jQuery JS, okay? And there's various different, there's a miniature, this UI version of jQuery, and this jQuery is for this non-UI, which is the backend communication. So usually you just include both of them, plus a modernizer that tells you whether this thing is supported or not. So yeah, you would do a modernizer check. Oh, this is not supported, then well, in this case, let me just build it from scratch, but let me enable this whole thing with a date type that is part of your jQuery. So there's a lot of these weird dependencies that happens in some contemporary code, and a lot of times you don't know if that code is actually backward compatible or not. But when you start seeing this modernizer and jQuery, then chances are this code is backward compatible. It's trying to build something, trying to test the modernization of your features using this approach. Anyway, so I won't get into too much details in there. You can kind of see the use of using a polyfill, and every time you see a polyfill, it just means backward compatibility check, okay, in implementations. So it's just a generic term that specifies that, hey, these are polyfill. I don't know why they call it polyfill, to be honest. I kept thinking when I first started doing this, polyfill means that you're trying to maybe build a polygon or something and fill them with a specific color. What does it have to do with the modernization and compatibility check, right? Like why would you come up with this misnomer? Anyway, this development journey has been an interesting experience nonetheless. All right, folks, I'm going to stop right here. Any questions about what we talked about? There's Modernizer on GitHub. Please go through these deep link, okay? And then we'll go back and double check on what we are today. Okay. Not gonna have the time, sorry, to go through the examples, but these examples are what comes after this, right? One of them is light out gain. This is very good, kind of a glorified lab assignment that I really want you to pay attention to, because you get to learn a lot from this. And there's another one, it's called weather comparisons. This makes use of Ajax, okay, to make something happens there. And again, spend at least an hour each example. You're gonna learn a lot from it. These are not difficult, okay? This is like, yeah, once you go through the whole the previous 3 sections, this is already an extension of it that gives you a lot of insights to it. Anyway, so this is all part of your homework assignment up until, so this will basically conclude our chapter 7 in its entirety, right? This entire thing. So I'm going to give you these 2 lab plus this homework assignment that consists of this all the way through 7.13, okay? Yeah, this is slightly reduced load compared to the week before, given Thanksgiving, and I want you to have a good Turkey Day with families and friends. Any questions? Sounds good. All right. So next week, please go through the calendar. I think this is pretty current. All right. So next week is 11/28. We're going to talk about regular expression classes. Honestly, I think we can probably get to this. Closure is another entire, I would probably spend a whole lecture just on closure, to be honest. But yeah, we'll see, okay? I don't know how far we can get to, but I want to be able to at least cover all of this by the end of the semesters here. And I usually don't go through any new topics, but because this is the 8th week, so maybe what we'll do is just have a take-home sort of thing, and then you know, with maybe 1 or 2, you know, last day assignment, because this is really the end of the semester. So I don't want to overdo it. If we can just pack everything here at this point, then you'll have plenty of assignment to do in lieu of having the final. Okay, there's no final for this class. It calls for completing all of the assignments, all of the labs and quizzes to the extent possible timely to earn your points, right? All right, any questions about what's to come next week? Yeah, next week is going to be this chapter, okay? Chapter 8. So we'll try our best maybe getting to this point. I think this will take a long time. But if we have time, maybe we'll go through this. Closures as well. So that'll give us, you know, this much time to go through week 7. But what I really want to do is get to these topics. These are event-driven network communication, take 3. Okay, so we'll maybe go quick on some of these, and then that way we can get to it. Yeah, we'll see. We'll adjust the cadence, but I want to make sure everyone is in with me on this, right?